So I think we can start. Can we? No. Something like this. Okay. I'm ready. Yeah. So welcome to our talk. This is the talk called Modernizing the CFEngine project. I'm Herman.
I'm Vratislav.
We work on CFEngine full-time in our company, which is called libntech. This doesn't work.
Did you turn it on?
I think I know. I just need to maybe focus.
Just turn it on.
There we go. Okay, here's the agenda for this talk. We'll go through some background and motivation, why we're talking about this, why we did this, and so on. Then we'll have three main areas of focus for the talk, and then a summary and conclusion in the end. The biggest part of this talk is about CI/CD, and most of it is not really CFEngine specific. So, start some background. Mark Burgess released CFEngine in 1993. He released it as an open source software on an FTP server with some kind of mailing list announcement. And it was something he was using to manage his infrastructure at Oslo City College or Oslo University. The big innovation was that it was declarative, not imperative, and was focused on a convergent state. And it was kind of Mark's research project, and also his research evolved with it, and it influenced each other both ways. In 2002, CFEngine 2 was released. It was focused largely on security, anomaly detection features, IPv6 support, and new encryption methods. And then in 2009, CFEngine 3 was released, which was a redesign of the language based on recent research that he did, and made it a lot more consistent and flexible in how you could structure your policy. So that's the background. Then for this talk, it's important to understand the project today, which is 25, 26 years later. It's a large C code base. It's evolved over all of these years. Currently about 100,000 lines of C code with multiple repos, multiple components. So we have the agent that's doing the changes on the system. We have a server which is serving policy, like a file server. We have an exec daemon, which is a scheduler and starts the agent runs and the other daemons. We have a monitoring process for sampling data, and then we have some enterprise-only processes for report collection, for showing a web UI, and so on. Another challenge is our platform support. We have very wide platform support. From the beginning, it wasn't specific to Linux or anything like this. It's meant to compile and run everywhere. So we support Windows, we support Linux, we support AIX, Solaris, HPUX, and we also have open source users using other platforms like macOS, different BSDs. Sometimes there's some Slackware contributions coming in. So it's used on everywhere where you can sort of run auto tools and compile something. A third important thing is we try to maintain backwards compatibility. CFEngine 2 to 3 was a big step and broke a lot of people's policy, obviously, because it was a redesign and it was painful for users to do this upgrade. So this is something we really don't want to do. So we're always trying to make sure that we have a clear upgrade path and it's not too difficult to deal with the changes that we have to make. We also have some users who are really pushing the limits of what we intended this software to do. So people are using undocumented, untested, unintended features. And from our perspective, they're bugs, but from the user perspective, they're features. So we also have to be careful in those situations. Here's the XKCD. Every change breaks someone's workflow. If you haven't seen it, it's about a CPU overheating in Emacs and somebody using that feature to trigger some functionality. So, yeah. Why did we pick Modernize for this talk? Really just because we didn't have a better word. I found the definition. It says modernize is to adjust something to modern needs or habits, typically by installing modern equipment or adopting modern ideas or methods. So I like this part about modern needs, which I think a lot of this talk is about. Yeah, so here's some areas where we had a few years ago kind of a general impression that these are things we want. We want to have increased development efficiency. We want to be able to make changes and have confidence that they're tested. In general, we want to reduce technical debt. That's a vague term. It can mean many things. We want our code to be maintainable. We want fast and easy code reviews. We want generally everything to be automated and not that much manual labor. Yeah, very general, and then sort of more narrowed down into 3 categories. We want a code base that's more modular, so it's easy to test individual parts of the code base. It's easier to reuse them in other projects. It's easier to understand because you have clear interfaces between the modules. We want a code base that's maintainable, so that's more along readability and understanding the code base, being able to make changes. And we want to improve our automation, which is a lot around CI, CD, release, to make those require less manual labor and give us more confidence that we have run the test, we are releasing something of great quality, and so on. And the final point here, more automated ways of finding and preventing bugs is always good, and being proactive about fixing bugs even before they're reported by users is good. Yeah. So the reason why we're having this talk now is because we've worked on this for a couple of years, and we want to share our experiences to those who are interested. So maybe you can learn something from our successes and also mistakes and what didn't work so well. So first up, modularity. Early idea here was that we wanted ways to test our networking protocol, to be able to make changes and find problems in it. We wanted to be able to build binaries that do have the networking code, but don't necessarily have all of the other parts of CFEngine included. And so we set this as sort of a project with tasks associated to it and started working on this. This part turned out quite difficult, to be honest. There's a lot of code over the years that's sort of interacting with the networking code. You can control things from policy. It has like a shared state with the networking code. So this part we decided to put on hold for now and focus on an easier, better first target. So that's this one. A smaller subset of something we can modularize is our basic functionality, like data structures, JSON parsing, memory allocation, string handling, and fallback implementations for missing C functions. And we made a library out of this. We started by forking the core repo, ripping out code, and then reintroducing it as a Git submodule in the core repo. And that works, and it's called libntech, library northern-tech. It was fairly easy to do this compared to the networking code. It's a nice place for being more aggressive about introducing new things because it's a smaller project. So we are seeing that some things like code coverage works better there because we have more deterministic tests there and fewer tests in general, so less complexity. We are starting to use this in new things now, most notably a new policy parser, syntax checker, and a part of the Mender project. There are some drawbacks here. Git submodules do cause some friction. It does require you to learn some extra commands, run some extra commands to update the submodule, to check out things in the submodules and things like this. So if you don't end up reusing this module in other projects, then it's probably not worth it. You can try to achieve the same things within the project by just making it modular in a folder, but not actually splitting it apart. Okay, now Vratislav will talk about CI.
Yeah, so I want to talk about continuous integration and continuous delivery. For those of you who saw Nick's talk yesterday, if you remember, in the last 2 years there were 15 releases. And as Ule pointed out, we are constantly doing some changes and improvements. So we really need some continuous integration and continuous delivery techniques, because otherwise we would not be able to do this. So first of all, we are actually doing continuous integration. In my previous job, I worked and came across many really baseline components in the Linux world altogether, and I was taken aback how many of these like critical components that are running everywhere had like no integration and non-continuous integration testing whatsoever. We started doing that in my previous job in my team, and we were basically discovering bugs in those critical components that we were relying on. So we are actually doing continuous integration, not only talking about it. Every pull request is tested. We have nightly builds of all the supported branches that we have, and also the master branch. We are using Travis, Jenkins, and some static checkers and memory usage checks. We will get to them later. And altogether, only in core and master files, we have 2,250 unit and acceptance tests, and then we have deployment and integration tests, which actually install the packages and try to do things on real, I would say real hardware, but it's actually virtual machines. But yeah, that's one of our problems. This is really not easy for us because we have many repositories. CFEngine is composed from many components, and we need to get them all together to run the tests. We have multiple branches. We have 3 LTS series supported, and then of course we want to run tests on master. We have many dependencies that we have to build, and we try to stay in touch with we try to stay on top of the development of those dependencies, because they usually fix some CVEs and other problems, and we need to have them fixed. So for example, now we are using PostgreSQL 12, and since we support RHEL 6, that's like something that was released 10 years ago and something that was released last year, and we just put it together and make it work. So this is also hard. We support many OS and architecture combinations, as you showed, and as I said, we are using virtual machines because containers are no real systems, and we cannot run the tests in containers because we actually need to test that our software actually can change the system state. So this is the Travis from, if you create a pull request, for example, we start a job in Travis. You can see these are the jobs that we run. So there's a lot of jobs for tests here, and then this is the 3 here are for master files, where we check that the master version or the PR version of master files can work with master 315x and 312x. Right now, Travis is cheap and fast. For the open source project, you get it for free. You don't have to pay. If you create a PR, very quickly you get a job that is running in Travis. So it's kind of first line of defense. That's what we do. So usually we create a PR, we wait if it's green in Jenkins, and then if it is, then we even dare to try running other tests. If it's red, we obviously fix it first. Unfortunately, in Travis, and unfortunately in many other places in today's world, Linux equals Ubuntu, which is, I don't know, me as a former Red Hat employee, it makes me really sad. But I think it's really unfortunate because I'm so not sure about Ubuntu being a good...
Try Debian.
Yeah, I mean, Debian is great, but you don't have Debian in Travis. It's only Ubuntu. It's Ubuntu, Windows, which we don't actually use right now for testing, but we test on macOS in Travis. And the tests in Travis, they are pretty simple. They usually just either build on Ubuntu, or they fetch the packages for Ubuntu and install them and do some basic stuff. So they are pretty easy to create. You can just test it on your laptop or VM Ubuntu and then do the same stuff in Travis. So very often it's a first step for introducing new tests. And then we get to the serious stuff, which is our Jenkins. And we have a multi-job PR pipeline project, or multi-job project called PR pipeline. These are the parameters that you can enter for starting a build. So these are all the repositories that you can specify, and then you can choose which kind of tests to run. And then if you want to run it on the exotics, which is AIX, HPUX, and Solaris, then you have to check it as an extra checkbox, because the capacity on these is very limited. The builds take forever there, so it's not on by default. And then you can filter the configurations. And this is then what you get. So as you can see, these are the 30 configurations that we run tests on. It's kind of a mess in the Jenkins UI, but I don't know. I don't know why they cannot make it nicer. And as a friend who helps us, we have bot Tom. It was introduced by Nick yesterday. It's an open source project written in Python, so anybody interested, you can go to this URL and check the sources. It's starting build in Jenkins, it's doing some checks, and one day it will surely take over the world, because we are constantly improving it, and it's not entirely AI yet, but one day it will. So it's simple as this. You just do cf bottom Jenkins, and then triggers a build, gives you the links to Jenkins and then the resulting packages. So this is really nice, because then you don't have to enter all these fields. It's like, it will pick up the PRs that are related to the program and like populate these fields with the PRs. And this is then the pipeline. It's doing things in multiple stages. I don't have to go into details, but as you can see, we do some canary builds, because running tests everywhere only to find out that they fail everywhere is not really nice. So we have some canary builds that are pretty fast actually. In this particular case, they were a bit slow, but these days they run for, you can get a build in less than 30 minutes. So in 30 minutes, you get the canary build, and then it moves on. As you can see, there is this exotics build, which in this case took 5 hours. So it's, yeah, like 3 times more than on the other platforms. And then we have some other tests, and all of these stages are running in parallel. So these 4 run at the same time, and these 2 run at the same time. And this is the new pipeline, which I created. Before that, there was a kind of not a modern PR pipeline, let's say. And it was very hard because we could only do like one PR pipeline per day, maybe, or like one full pipeline run per day. When I was making the slides, I checked that we had more than 5,300 runs of the pipeline, and it was created on February 1st, 2018. So that's roughly 7 runs per day, and it's much more configurable, so you can skip different parts. So of course, not all of these 5,300 runs were doing all of this and taking 4 hours. Some of them were maybe just the canary build, which take like 30 minutes. And we are using build nodes in AWS, but recently we have started migrating some of them back to our one server, and we are using Vagrant to create these build VMs because they are just much faster than the AWS build slaves and cheaper. And a thing that was actually merged yesterday and almost reverted today because it broke some stuff. You can now, if you run autogen and make in the local clone of the core Git repository, you have always been able to do make check, which run make check in unit tests and acceptance tests. But the problem with this is that some of the tests that are not really safe to run on your laptop or machine, because they do actually modify the system, because we actually want to test that our code works and does the changes. So this, if you do this on your laptop, it will skip quite a lot of tests, and also it will use the local dependencies. So I don't know, we are using LMDB, for example, so it will use the LMDB provided by your distribution. But if you run, if we build things, we actually build LMDB and make it part of the CFEngine. So now, since yesterday, you can do make VM check and make VM check full. And this make VM check full actually builds all the dependencies that we need. And this is equivalent to what we do in Jenkins. So if you submit a PR, it fails in our Jenkins. It's not really hard. It's not easy for us to give you access to Jenkins because, yeah, it's Jenkins. You don't run Jenkins in a publicly reachable place. So instead, now we can do this, and it will run what we do in Jenkins, but on your laptop in a VM. And yeah, last but not least, I mentioned continuous delivery as well. We are doing nightly community package builds. As you can see, there is a build history from the last couple days before I was making the presentation. It's building a limited number of platforms. What we support, or not support, but what we provide as community build. So it's just Debian, Ubuntu, and CentOS ORL. And if you go to this page, it's a new page created last week. You can actually get the nightly builds and start using them, testing them if you want to. And yeah, that's all for me. Ule can continue with other great things we are doing.
Yeah. So, as mentioned earlier, we want to be more proactive about finding kind of the difficult bugs, the security bugs, and things like this. And so a while ago, we started using something called semlql, or lgtm.com, which is now acquired by GitHub. And it's a code analysis platform for, primarily it's targeted for finding security issues in your code. And it's a query language like SQL that builds your code base or parses it if it's something like JavaScript, creates the syntax tree, and then you can run queries on that syntax tree for patterns. And it's a full-blown programming language, so you can find really interesting things. They even have examples of some like source and sink, and like ensuring that input is sanitized when it comes from this source through a code path and goes to Postgres, for example. So it has a lot of cool features, especially for a C or C++ project. There's a lot of unsafe things you can do in C and C++. And so having these kind of extra measures helps you a long way in preventing those things. It's free for open source projects. It's not open source itself. They have a hosted platform on lgtm.com, and it's going to be more integrated with GitHub soon. It's a part of GitHub's Security Lab initiative. So they acquired this. They're using the PandaBot, and they have various other initiatives for improving the security of open source projects. The basic idea and what's really nice for us is that you can fix a bug and then make a query to ensure that all variants of that problem is fixed, and it will run on all PRs to ensure that nobody reintroduces a similar bug in the future. Yeah, here's the available languages. They just dropped Fortran support. Sorry. I guess it wasn't worth it. This is what it looks like. Here's a query that looks for function calls of string copy in C. And there's a alert message that tells you to use a safer alternative instead. Then this will run on your code base. You can do it in their web console, and it will give you all of the places where you use str copy. Point to the line and let you fix that. Also, when you enable pull request reviews, they have a bot that will comment and says, like, here's a new alert, here's the message. You can click there, and it shows the line that you introduced that problem, which is very good because when you enable this, they will have hundreds of alerts that you kind of want to fix. But it enables you to only sort of really care about not introducing new things. So you can get rid of the existing alerts at your own pace, and in the PRs, it will only show you the new alerts that you're introducing. Yeah, when you click the link, it pops up this UI with line numbers, and yeah, here's the use of strcpy for this example. They also, I haven't shown it here, but they also allow you, when you write your custom queries, which we started doing, they allow you in the question mark there to specify a documentation page. So for our code reviews, we can sort of give a really nice documentation of like what's wrong with the code, how should you fix this? What do we want you to do to fix this problem? So it's very nice for automating code reviews in a way. Yeah, that's that. Another thing that is generally considered good is to have a grasp of how much of your code base is covered by tests. So this is a compiler option that you enable that creates these files that track which parts of the code base your tests hit. And then there's a hosted service called codecov.io, where in your CI you can, at the end of the run, upload to this service, and they will do similar things like comment on the PR and show you in an interface what are the changes. It's quite easy to introduce. If you do anything wrong, there's no feedback whatsoever. So you have to contact their support, and they're very helpful, but I wish they would show me some logs or something, because there's like nothing. But we managed to get it working, and working in different projects. It works great in libntech, where the tests are deterministic and clear and not that complicated. But for the whole CFEngine project, we are running tests where you have a server running and a client running, client connecting, there's different timings, and then you're terminating the server, and sometimes it terminates in a different path than other times, depending on where it is. So it doesn't work great in core, unfortunately. And that's why on this graph here, on our PRs, it's like varying all the time by like less than 1%, like 0.02% or something, because there's like a couple of lines that are sort of random if you hit them or not. And they don't have a good way to deal with that, apart from us needing to go in and disable the whole thing for those tests, and we haven't done that yet. So yeah, it's kind of a codecov it's nice when it works, but it might be difficult to introduce to large projects. Then probably my favorite, AddressSanitizer. This is a flag that's built into the big C compilers, Clang and GCC. You need to give it as a compiler flag and a linker flag. It adds special instrumentation to your binaries, special instructions, and it also links to a shared object library to replace the normal malloc and things like this. And what it does is it finds a lot of memory safety problems. It's similar to valgrind, so most people have heard of valgrind before, but it does require a compilation. It does require this instrumentation, but this means that they can detect problems that are on the stack. They can detect overflows, a lot more things that you don't get in valgrind. And we have enabled this for unit tests. It has found a lot of problems that we've fixed. And yeah, overall, very happy with how that's working. Here's how you enable it. It's not that important, but here's the flag, fsanitize address, fsanitize address. You need to do that both when you're compiling the code and when you're compiling the tests and running the tests. So if you do something like this, as an example, if you have 3 arrays and you have a programming mistake here, so you're iterating over 101 instead of 100 elements, depending on your stack layout, then you will sort of hit one of these buffers instead when you go past it. And this is not something that valgrind can detect, but ASAN does detect it. It gives you a stack trace, it gives you a memory layout, it has sort of all the information that you need. It says that this is a memory access at offset 132, overflows this variable. It's very useful. We also introduced valgrind. Like I said, ASAN requires a recompilation, and in some cases it's easier to add valgrind because you don't need that. And we've had quite a few memory leaks in the project that were sort of missed because people didn't manually run valgrind in sort of all the different scenarios that we want to, and now we have a test which does do that. So this test starts the daemons, file server and executor in the background. It does some basic things like key generation, bootstrap, update, and evaluation. Make sure that there's absolutely no errors in the logs, no ASAN, no valgrind errors. And it's just a bash script. It's really easy to understand and write. And for me, this is very, very good because it didn't take that long to write this test, and it's provided so much value since I did it. Yeah, this is what it looks like. You can run binaries with valgrind. Here's the options that we use. You can share the slides so you don't have to take pictures. And then we basically run some grep commands on the output files, make sure that they include the lines that you expect and don't include the lines that you don't expect. And then similar for server process, you just have to background it, and then we save the PID so that later we can ensure that that PID is still running and kill that PID so that the process gets the cleanup and gets the valgrind output, because you can't just sig kill the process, then you don't get the valgrind output. And then in the end we do the same, we grep the output for things. One last thing, We've done some fuzz testing. For those who don't know, fuzz testing is taking a known good input and altering it randomly and seeing if the binary crashes or does something weird. So we've done this on our parser. The real revolution in fuzzing over the last few years has been guided fuzzing, which means that the binaries are instrumented, and when they find new code paths, they prefer kind of those advancements. Instead of just doing something random, they try to look for situation which causes the binary to go down a different code path. It's great for parsers, but CFEngine is not just a parser, so it's a little bit tricky. Sometimes you can get the agent to hang, or it makes some changes to the system or something like this. So it's not so easy. I've done this manually in an AWS instance, found and fixed quite a few issues in the parser. There are ways to enter your project into automated fuzzing efforts. So there's Google OSS Fuzz, which is for all open source projects. There's also projects who are focusing on the kernel, fuzzing system calls. But we haven't done this yet. We've just done it manually so far, and it will take some more work to be ready to introduce it to an automated system. Yeah. Here's the basic script for getting it running. It's also very easy to get started, which is great. You just clone and compile AFL, which is like a different implementation of GCC, or a wrapper around GCC. You need to set some core pattern. AFL utils is a Python tool which makes it easy to run parallel fuzzers. So typically, I run multi-core here with 8 fuzzers. It's very simple. You just copy over some examples into the inputs, and then it gives you an output folder with the files that cause a crash, with the policy file that causes the agent to crash. We're good on time? Maybe? Yeah. Okay, so finally, and on a different, more high-level note, we've been looking at ways to increase contributions to make it easier for others to contribute to the project. And first of all, here's a part of our, it used to be called hacking.md, but we went more with the standardized contributing.md and reworded a lot of things. So it used to be very negative, in my opinion. It's like top reasons why you're going to be rejected. So I tried to make it more positive, more to the point. Also make the formatting better with like more examples and clear guidelines for what we mean when we say we want you to do this in one way, and a reasoning for kind of why. Another thing is we added this filter for issues that are easy to get started with. So if you want to contribute to CFEngine, there's now a filter in our Jira that gives you easy to do tasks that are open. And there's a few websites where you can sort of share this filter. So this is upforgrabs.net. So anyone who's interested in contributing to an open source project can find CFEngine there, get a link to our contribution guidelines, and a link to the easy tickets to start with. So, in summary, these are the things that we experienced to work well. Contributions are increasing over the last few years, and it's easier to handle new contributors now when we have sort of clear systems and guidelines to point them to. In an internal survey, our own perception of our code base health is improving. The CI that Vratislav talked about is much more effective than it used to be. We're using it a lot more, and we're able to be more confident about making changes. GitHub CodeQL was easy to introduce and provides a lot of value. Valgrind and AddressSanitizer, pretty much the same. What's also great about these tools is that you don't have to write more test cases. They all sort of rely on our existing test cases. It's just using tooling to make it more effective, which is great. Some problems, as I mentioned earlier, codecov can be difficult for complicated projects. Some problems are more difficult than we think, like restructuring all of the networking code. We probably could have planned this better, but I think in those cases it's also important to reevaluate and react and say maybe it's better to focus on something else first. And finally, Git submodules do add some overhead. Excuse me. So it's something to consider whether it's worth it to split out the library or not. We probably wouldn't split the CFEngine repo into 5, 10. It doesn't make sense. But if we have something clear and we actually want to use it in another project, then it does make sense. Thank you. Thank you for coming. Thank you to Mark Burgess for writing CFEngine and a lot of the things that he's contributed to this community. Thanks to all of our contributors over more than 25 years now. And thank you to Cfgmgmtcamp for having us. Sorry, my throat is. Do you have any questions?
Yes. I once tried to use valgrind to find a memory leak in a scripting language, and I got lots of false positives because the scripting language did garbage collection. Did you get a lot of false positives from valgrind? Is the address sanitizer better?
Yes and yes. So valgrind and these tools are, I think, primarily intended for compiled code. So it's sort of it's like Perl or Python's job to fix the issues in their code, and then these things shouldn't really be something that you are introducing in the high-level language. We have seen some issues with valgrind, some false positives in libraries that we're using, so not our code, but generally they have been fixed in newer versions of valgrind and newer versions of the libraries. So it's a good idea to run valgrind on something as recent as possible. Like now we're using Ubuntu 16 or 18 in Travis.
And it was failing on Ubuntu 14.
Yeah. That was the main reason why we upgraded our Travis to 16.
But I wasn't looking for bugs in the scripting, in the script code, in the C code of that scripting.
Oh yeah. So then that makes sense. Yes.
Whenever it created a thread and later deleted the thread, it leaked memory, and
yes.
I was unable to find that.
Yes, I had an issue the other day that was with threaded code. It was really difficult to see with valgrind, and especially because sometimes valgrind detects these issues a little late. So like you corrupt the memory previously in the program, and then something bad happens later, but then you don't know where the actual problem is. You just know that it's like sometime before. So this can be a problem.
Yeah, and there's also a limitation that valgrind makes everything, it serializes everything, so it doesn't support multiple threads. So then you get really different results. And also, when I was once using it for like finding some bottlenecks in the code for like for the server process, it made it super slow, and the results were like totally far away from reality, because now everything was serialized, and so the results I got were totally different than what's actually happening in real. But I think that ASAN is much better in this.
Yeah, so some backstory. ASAN was made primarily by the Google, I don't know what they call it, it's the safety, like internal team for improving safety and tooling. So valgrind was not good for them for finding problems in Chrome, because it made Chrome way too slow to run. So ASAN has a lot better performance as well. The performance overhead is something like 20 to 30% slower typically, and I think memory in general like twice as big memory footprint. So it's reasonable even for a very large piece of software.
Yeah, just one note. I don't think it was if Uwe said it with libntech, this new library we created. It would be great that if not only us use it for multiple projects, but it's really open source C library. It's kind of like STD library for C. It's like the C++ STD library. So feel free to use it if you want to. If you need like hash maps, sequences, vectors, queues, threaded queues, mutexes, whatever. It has really, I don't know the number of functions, but it's crazy number of very useful functions that we use all over the code base. And any contributors and any contributions there would be just welcome. So if you need if you are not happy with like the standard C functions and you need a bit more, then it might be a great candidate.
Yeah, it also has the big benefit that it's tested by us on so many different platforms. So
yeah, exactly.
You get that kind of for free.
Any other questions?